Okay, so one extremely one extremely important protocol is the network time protocol. To know and to implement network time protocol, the NTP, which is responsible for making all the devices in your network synchronized together and have a correct world timing, global timing, not some specific local timing, but it's a world global timing, because maybe your network is worldwide and you have routers multiple in multiple provinces, areas, states, countries, or whatever. So you need some server that do distribute and synchronize time and date to all your devices. The big benefit of that is that when some error happens and you want to troubleshoot your network and see the message, you know that at Tuesday, maybe January 13th, and at the time exactly the clock of maybe hour 01 minute 30 and the second 7, OSPF was down and up repeatedly. So you know that there is an OSPF flapping happening at that exact time. Maybe you go to other side of the OSPF and see the same message or not. Maybe after that you'll find that just 1 minute before this happens, or half a minute before that, someone has typed an incorrect command causing all of this. So this will make you know exactly the timing that an error or a message appeared or happened while you are troubleshooting. Of course, it will lead you to troubleshoot much faster by knowing what exactly happened at that time and caused my devices to behave this way. Another thing, timing and synchronizing is very important between devices for even more realistic results and cooperating between the devices. So NTP is the protocol responsible for timing and synchronizing between devices, or give it precise information with real timing and date. Okay, it's either by setting an inner clock manually, this can be done, no problem, we can do that, or by asking someone, and by someone I mean an NTP server, to inform us about timing. NTP uses UDP as a protocol with a port of 123. Each network device, each router can be either an NTP server or an NTP client. This is normal. It's okay because you can, like DHCP, make your device as an NTP server, like your router, create a clock by using the command of set clock inside your router, and give a specific timing and date totally, and after that make all the other routers connected to it. So okay, so this router in here is an NTP server, and these also other routers in the same network and all connected together, and these also are routers, but these are NTP clients. As simple as that. Okay, we will see the difference between the config, whether I want to config one as a network server and the other a client. In the lab, we will implement two routers, same model, same routers, but we will like one of them an NTP server and the other one is an NTP client. As simple as that. So another thing you must know, another term you will find only in the NTP protocol, which is stratum. Stratum means the source of the timing, the source that is providing timing and calendar, whether this source was a real server, a router behaving like an NTP server, maybe a worldwide global company or service that is providing timing freely for all the world, that I would take my time and synchronize my timing with this one, like GPS as an example. Stratum is also available for multiple sources for the single device. What I mean by that is that I can make my network have multiple timing resources. Just in case one of them went down, I just go automatically NTP will redirect the NTP, the timing requests automatically to another timing source. I can have about 16 stratum, just I am showing it here. Okay, and they will be preferred based on a number. Okay, I can get up to 16 timing source at one time, starting from stratum 0 reaching stratum 15. The big important thing is that organizing the stratum per order, like making stratum 0, stratum 1, 2, 3, will decide which one is more preferred to depend on, and which one is the other second preferred and the third preferred NTP server. This is done by the stratum number. Stratum 0 is the highest preferred. This is if there is a stratum 0 in your network, then all your devices will look just to this server. They will synchronize timing only with this server, not with any other one. If you have stratum 1, this will be second preferred, stratum 2, 3, etc. In Cisco devices, just in case you have created a server and a router and make it an NTP server, this router make it an NTP server, it will be negotiated to the other clients that this device is a stratum 8. So just in case there was any other stratum which is higher, more preferred, like stratum 7, 6, 5, 4 up to 0 available in the network, of course your devices, your clients will negotiate or will synchronize with the most preferred, not with this one with stratum of 8. But also stratum number is editable in the Cisco router, so you can create a Cisco router and make it an NTP server with stratum number 5, 6, or this way. Also, another note that you must know about stratums: stratum numbers are stratum numbers are more preferred, and in this case you will find the more preferred stratum number indicates a stratum NTP server, an NTP server that is very close to me and it's much faster in responding. Like maybe just in case in your network you decided to operate two NTP servers, two routers, you made two routers behaving as an NTP servers. The routers will look for the closest one as maybe stratum 4 and for the further one as stratum 6, because it prefers the one closest, because it doesn't want to jump very multiple hops just in order to reach the first NTP server and to synchronize between the clients and the server. So the closest, the more preferred, the closest, the better, just as the slides mention in here. Okay, so for NTP, just we have talked about, this is only the concept of NTP. This is all I'm talking about. It's only a network timing protocol. It just provides timing to your network by synchronizing with a global server knowing, or just create your inner clock inside. It will be rarely to use an inner clock inside, as long as your network is using internet and internet is provided. Of course you will set an inner clock but with a high stratum like stratum 10 and leave it alone, or stratum 8, but you can connect your network to a GPS or to an atomic clock. An atomic clock is some type of invention that gives you a precise timing, the most at all in the universe. It's a very expensive device to buy. I believe it's $2 million, such thing. I've heard such information. And also, I believe it gives you stratum 1. And after that, stratum 2, 3, and 4 are available for you to connect, like GPS and like some, I believe also there is some NTP servers available and provided from NASA company. So these are the global and well-known satellites and services that gives to the worldwide the same timing at the same time. So if you have like 10 routers, each one of them in a country, all of them will have the same timing because maybe all of them are connected to the GPS. So this is the benefit. So whatever happens between all of them, you know the behavior of all the 10 routers is recorded at the same timing, and you can compare between them and know exactly the actions that are happening at the same second or moment that you want to check or troubleshoot at it. So for the lab part, okay, so for the lab, for the pack tracer, we will have two routers. I will make one of them as an NTP server and the other one as the NTP client. So connect these together. Let's have a network between them, which will be 10.10.10.0/30. Okay, so for the first one, no, of course, enable config terminal interface fast ethernet 00. Let's give it the IP address of 10.10.10.1 this way, no shutdown, and exit again. Now to make this one as an NTP server, first we must specify a clock or set a clock manually, an inner clock. So clock set, let's see, this version requires hours colon minutes colon seconds, so it's hour 00 and minute maybe 10 with no other. Okay, so the day of the month, it's maybe 10. I do a space. The month of the year, we are in January and it's 2020. So now I've created an hour that will start syncing from now. Will it? Okay, we have passed 4 seconds so far, 9 seconds, etc. You can see this. No problem. After that, let's just specify an NTP master. I can either specify it any number from 1 to 15 or leave it by default, which will be NTP master 8. And let's go to the other one. It's still down and it has no idea, but it will sync once we make it an NTP client. Enable configure T or config T interface fast ethernet 00, IP add of 10.10.10.2 this way, no shutdown. Good. Let's do one thing to show clock. Okay, it's something the default inner, which is when it was operated and modified. Let's sync with the main one. This will be done by configuring an NTP server and give it the IP address of the NTP server, which is 10.10.10.1. We can specify a key for authentication. This is not required for you, I believe, but you can authenticate this. We will talk about authentication in the security chapter. Okay, so specifying an NTP server should be enough. Let's see if this will solve it. Show clock. No, it did not yet. If I am missing any command, config T, NTP, update calendar, and still no. For this one, please show NTP associations. There is one associated, but it's not that one. Show NTP status. The clock is synchronized as Stratum 8. Show clock. It's the correct one that we have set. No problem. Okay, let's see if I'm missing anything. No, I'm not. I wonder why it's not syncing with it. Some fast forward. Show clock. Finally. But does it really take all that time? It's UDP connection. Okay, so right now my NTP client, I did not set any clock in here. I only set an NTP server, which is this one. Where is it, please? The NTP server, to get a reference of timing from this one. And after that, I also, the other command is very important, the NTP update calendar, to update the calendar, not only the hour. okay, to update the timing of the calendar, which is this one, Friday, January 10th, 2020. Okay, without this one, it will remain this way, but it will only update the clock to become at hour 0 and minute 13. So this is how to configure the NTP master and client. Both of them are routers actually. Both of them are the same model, the same devices, but NTP can be configured either a master, a server or a client in the devices. If you have watched the DHCP videos, the DHCP subchapter, what I had at that time is that I have configured my router as a DHCP server and my end devices as DHCP clients, but also you can configure a router interface for DHCP client also. You can make a router a DHCP client just in case it was connected to other router which is a DHCP server, and this will automatically give an IP and a subnet mask to this interface of the router which is acting as a DHCP client. So this is NTP as a concept and as a lab, just in case anything was missing or incorrect or maybe not clear, just please inform me down below, comment in a video, and I will do my best to clear it even more. Thank you for watching and hope to see you in the upcoming video. Goodbye.